For the final transformation, we're going to talk about reflections. Let's see it. Let's see it. Or flips. And how do we flip? We flip over the x-axis, like so, which means it's vertical. And we flip over the y-axis, like so, which means it's a horizontal flip. Okay? So let's say we have the point 2, 4. If I flip it over the y-axis, where's it going to end up? Where does it end up? Negative 2, 4. You sure? If I flip it over the x-axis. No, I said over the x-axis. What is it? 2, -4. What changed? The y value. So when we have a negative in front, that means a flip over the x or a vertical flip. Okay? So that's vertical over the x-axis. If, oh, sorry, fine, see correctly. Should be there. If I flip it horizontally, where does it end up? -2, 4. So if I flip it horizontally, it's 2 away from the y-axis, which means the horizontal flip is going to be 2 away on the other side, or -2, 4. And we can see that the x changes sign. That is a horizontal one. And it flips over the y-axis. So just to look at each one in a little bit more detail and do a couple of examples. Okay. We just saw when we flip points, it's the same thing when you flip graphs. Like if you flip a line, if you flip a parabola, if you flip a circle, if you flip a weird looking shape like this, like a W. Okay. Every y value is going to change sign. And if it's below, if you flip it above, it's going to change from negative to positive. So here we have an example. No idea the equation of this graph. Okay, doesn't matter though, because all you're asked to do is find a vertical reflection. Remember, if the negative's on the outside, it's a vertical flip. Okay, so you could use mapping notation. I left it available there. Or you could probably do these ones in your head. Okay, so basically, take the arrowheads, flip them, so they're 4 above the x, flip them 4 down. Take this point, it's 2 above the x, flip it 2 down. When I flip these 2, where do they go? They stay exactly where they are. So it's going to look like this. You could have used mapping notation. You could have said, okay, this point is -5, 4. This is -1, 0, 0, 2, 1, 0, and 5, 4, and then change all the y coordinates and replot and connect the graph. Okay? But that's all you need to do. Any invariant points? You should be familiar with what those are. 1, 0 and -1, 0. Okay. This one, you're asked to graph this function. You should be familiar with how to graph these. It's a parabola that instead of starting its vertex at 0, 0, where does it go? Instead of starting its vertex here, it starts down 4 because of the -4 at the end. So it's going to be here, and then we can go 1, 1, across and up, back to the vertex, 2 across, 4 up, and there's our f of x. On the grid, I want you to sketch negative f of x. Or sorry, not g, it's not f of x, it's g of x. I want you to sketch negative g of x. You should be able to do that. We've got 5 reference points we can use that we can flip and then redraw from there. So you flip vertically or over the x-axis, it look like that. And that's negative g of x. Okay. What do you think? I'm not sure why I put this space here. What do you think the equation of the negative g of x is? Just plus 4? X squared plus 4? Almost. Negative x squared plus 4, because it opens down, right?
But that negative doesn't change anything.
So, well, what it does is to go from here to here, we take the negative of all the terms in the equation. So it becomes negative x squared plus 4. Which makes sense because from here we move up 4 and the negative tells us it opens down. Okay, so when you want to change an equation with a vertical flip, you take the negative of everything in that equation. Any invariant points?
Oh.
Yeah, oh yeah, you're right. What's wrong with my counting today? What, why didn't somebody correct me? Oh yeah, wait a minute. Okay, yeah, no, I get that. I'll just sit here and talk to myself. What you guys worry about? Okay, oh, that's all right. Yes, the invariant points are -2, 0, and 2. So that's vertical. Horizontal flip. Is when the negative goes inside in front of the x. Goes inside the bottom. Okay? So, and when we do a horizontal flip, every x value changes sign. So here we're given another graph of a function f of x, and this time we're asked to graph f of negative x. Well, I mean, you could use snappy notation. I didn't put the table here, but you could, of course, use it. Or you could just go straight to the graph and flip everything over the y-axis. So I could go, all right, this is 5 away, sorry, yeah, this is 5 away from the y. So it's going to go over there. This one's going to flip over here. I'm going to keep track. This one flips where? Does stays exactly where it is. This one flips here, and I'm going to connect. This one flips over here. Make sure it's an arrowhead. And you got it. Invariant point. 0, 2. Okay. So that's being given a graph and asked to sketch its reflection. This is a more uncommon question. It would like, I doubt you would see one like this on the provincial, where you're asked to sketch a parabola. Okay, but it doesn't hurt to remember. Where's the vertex of this parabola? 1, 9, -1, -9. Because it moves 1 left, 9 down. Make sure I'm counting correctly this time. 2, 2, 3, 6, 2, 3, 4. So that's h of x, the purple one. And now we want to sketch h of -x. Well, take those 5 points, flip them over the y. So this one goes here. This one goes here. This one goes here. This one doesn't move. And then this one goes over here. So it's going to look like this. How do you write the equation of a horizontally flipped function? Only put a negative in front of the x. You don't have to put a negative in front of anything else. So the equation of a horizontal flip of this one would be just put a negative in front of the x. Everything else stays the same. Like so. Now, we didn't graph ones that looked like this that had a negative x, but I could rearrange this. It is, in fact, this graph. Okay, but I'm not going to worry about it. So to change the equation of a horizontal, sorry, of a vertically flipped, you have to put a negative in front of every term. If it's horizontally flipped, you put a negative only in front of the x. Invariant point, well, there's one right here. That's 0, -8. Okay. All right. That is